Welcome back. This lesson we're going to be looking at piecewise functions, also known as hybrid functions. Now, the notation might look a little bit confusing at first, but if we look at it one line at a time, so I've started off with an example, done this video a little bit differently. If we look at one line of it, if I just wrote g of x is equal to x minus 5, comma 1 is less than or equal to x, which is less than or equal to 5, you go, well, hey, I'm just sketching a straight line with the equation x minus 5, and I'm sketching it between x is 1 and x is 5. It doesn't look too daunting. All the hybrid function is that for parts of the domain you can have a different rule. So it's almost like you're sketching three separate equations with restricted domains on the same set of axes. Now, for it to be a function, it still has to pass our vertical line test. So if you look at the domains here, you'll notice that the first equation is for everything where x is less than 1, and the second one is when it's equal to or greater than 1. You won't get it equal to the same point, right? If it's going to have two different y values, it won't pass the vertical line test. Some of them will meet at the same point, others there might be a bit of a gap in there. So let's have a look at this one and go through the process together by hand, and then I'll show you on a CAS calculator to see if we've got it right. So when you start with this, always start with the top one. We're just sketching for all the values for x is less than 1. So I'm going to draw my axes, and I'm drawing the line negative x minus 3. So you know, well, at y equals 0, I'm going to have, at x equals 0, I'm going to have a y-intercept of negative 3, and it's a negative gradient. So it's going to be some line that's coming down like this. Okay, and I want to stop it at positive 1. Now, x is less than 1, so that's going to go up to negative infinity. This point here, I'm going to have look at my domain. It's less than 1, it's not equal to, so I'm going to have a hollow dot there. And so let's substitute in 1. So if I find what is g of x at x equals 1, I can write as g of 1, so that'd be giving me negative, and instead of writing x, I'm putting in my positive 1. I'd get negative 1 minus 3, so it's going to be negative 4. So this point down here is 1, negative 4. That's that point. And now I've just sketched that first part of it. Now I'm going to use a different color here. I'm going to use orange for the middle part. So now the middle part, I'm sketching x minus 5. And I go, well, at minus 5, that would be my line, but it's got a positive gradient, so it's going to be coming up. Now, it would like something like that. I don't know. Let's find out. What I'm going to do first is I'm going to put in the number 1, because I've already got a point there, 1, negative 4 for the first part of the equation. I want to find out, does it hit that same point, or does it start somewhere else? So if I substitute in g of 1 for that equation, I'd get 1 minus 5, which is negative 4. So good news is it starts at that point. So it's a colored in circle, and it's got a gradient of 1, so it's going to be going up this way. Now it goes all the way up to x equals 5. So let's find g of 5 to find out where it ends. So I'm just substituting in the endpoints of the domain here. So when it's 5, it's going to equal that middle equation. So it's 5 minus 5, which equals 0. So up here, and it's equal to, so I'm going to have a colored in dot, it's going to get to 5, 0. And the last one I'll do in green. We've got x is greater than 5. So let's find out if 5 was in this bottom one. I'd have 5 times 3 is 15, minus 15 is 0. So it's at the same point, and it's got a gradient of 3. So it's going to come up a lot steeper. So it's going to go up that way. Now we can sub in another point if you wanted to show where the gradient was. We've got intercepts labeled here and here. So let's just put another point in. Let's say at x equals 6, I'd have 18 minus 15, so that'd be a positive 3. So that'd be 6, 3. All right. So we can see that it's three linear equations all joined together at the points. Now they don't have to join, but for this one, it just so happens that they did. So to recap, treat it one line at a time. So start with your top line and just sketch that with that domain. Find your endpoints by putting in or subbing in the values that are given that restricted domain. Then once you've done that one, work your way down to the middle one. And then again, sub in the endpoints. So I found g of 1 was at negative 4, g of 5 was at 0. So that's the 2 points, and I connected it with a straight line. And then the last one is everything greater than 5, and I knew it was a straight line. You might have a root graph, you might have a parabola for part of it. Doesn't matter what the equation is. Start with the point where the domains meet, and that's where your turning off point is. If you go, you can see it's going across an axes during that time, find your intercept values to give you a point of reference to connect your lines. Okay, take it one line at a time, use the domains to find the endpoints. And you might end up having some very interesting ones. You might have, I don't know, the first part of a parabola that's coming down, then you might have, and let's say it's equal to there, and then the next one might actually start up here at a hollow dot and have a linear graph part, and then you might have part of a root graph finishing it off over here. But as you draw your vertical line test, you go, hey, doesn't cross there, crosses that once. So it's still a function, right? It's not continuous, but it's still a function because it passed the vertical line test. So they don't have to be straight lines. You get some really interesting creative ones, but just take it one step at a time. Okay, so that's a brief intro to piecewise functions. Let's have a look at a CAS calculator. So if we go to graph and table, clear whatever you've got in there. Alright, get rid of all that junk. So you can type in each of these equations one at a time if you wanted to. So I'm going to type in negative x minus 3, and I'm going to type in x minus 5, and I'll type in 3x minus 15. And if I tick all those and sketch them, I'm going to get 3 continuous lines. So they all intersect and go, well, it doesn't quite look like what I drew here, but you notice here that their lines continue on forever. So I haven't actually restricted the domain. So to do that on your CAS calculator, so just navigate up to the top. You can just touch on your touchscreen, use your arrows. If you go to keyboard and then go to math 3, so keyboard math 3, this vertical line all the way over here, right, it lets you restrict the domain for each of these graphs. So I've put the vertical line in, and then I'm going to put in x is less than 1. So if I type x is less than 1, you'll notice that those greater than less than signs are on the same page. All right, and then hit graph. You know, so now it chops the blue graph off where I restricted it. So let's do the same for this one. So again, keyboard, math 3, vertical line, and then we can put in 1 first, less than or equal to x, which is less than or equal to 5. And for the green one, while we're here, x is greater than 5. Again, make sure they're all ticked, hit your draw button, and you can see, hey, that looks like we've done here. Almost use the same colors too. I didn't even sync that up. All right, all the best for this chapter. See you next lesson.